All right, welcome back, everybody. Today we're going to be talking about SGR7. This is our radical review. We're just going to touch upon a couple of the topics that we've been working on the last week or so as we start to prepare for our upcoming test that will be on Thursday. So I will take care of the odd problems today, and I'll let you guys do the evens. We may jump around just a little bit. First thing we're being asked to do is to graph this. Now, remember, when we graph this, a couple of things we want to do. We want to start by always looking at our equation. Remember, if there's no number in front, you could put a little 1 in there. In this case, it would be a -1. Now, when we start to think about these numbers and what they do to our graph, remember the number on the outside is going to determine whether our graph shifts up or shifts down, whereas the number on the inside is going to determine whether our graph shifts left or shifts right. Now, the guy on the outside always tells us the truth. So in this situation, when I see a +5, I know that means I'm going to shift my graph upwards. Unfortunately, the guy on the inside always tells us a lie. So +2 would make us think that we want to go to the right, but when we realize that he's the liar, we really want to sit there and actually go left. So what that means is you want to take your vertex that normally would have started at the point 0, 0, and you want to shift it up 5, 1, 2, 3, 4, 5, and then left 2. Now, after you get this spot, you've done a really good job. This is what we call the starting point or the vertex of our graph. In particular, this would be at the point -2, 5. So down here, we can come and list our vertex at -2, 5, just like so. And then what we also want to do is put that starting point on the very top line of our table. Now, there's been a pattern we've been working with for the x values this entire time. After you get your first starting x value, you just want to add 1 to that to get your next x value. So -2 plus 1 is -1. Then you want to add 3. -1 plus 3 is 2. And then finally, you want to add 5, and we'll get to 7. Normally, we don't worry about this last row. That 1, 3, 5 is always going to be the pattern that we use on the x's as soon as we have our starting point. Now, for the y value, that pattern is going to change depending on your given function. And in particular, it's going to change based on this number. In this case, we can see that we have a -1. So what we're going to do is we are going to subtract 1 from this number each time. 5 take away 1 is 4. 4 take away 1 is 3. 3 take away 1 is 2. If this would have been any other number, such as 2, for example, since 2 would be positive, we would add 2 each time. If this would have been a -3, we would have subtracted 3 each time. Now, once we have those, we just want to come over and graph our points. -1, 4 would be right there. 2, 3 would be right there. 1, 2, 3, 4, 5, 6, 7, 2 would be right there. And then we want to just sketch our graph. Now, when we come over here and we start to think about domain and range, the word I gave you to think about these is x-dry. I can spell x dry. And the reason we say x dry is because the x values are our domain values and the range values are our y values. So when we look at this, if you recall, we normally say x and y right here, and then we look to our table. So up here I can see that the starting x value was a -2, so I'm going to come and put -2 right here, and that my starting y value was 5. So I'm going to come and put y over here. Now, as we think about this, we just need to be very careful. If we look at our graph here, or even at our table, what we can see is that all of the other x values are bigger than that starting x value. So all of the other x's are bigger, so we're going to say x is greater than or equal to -2. Similarly to that, for our y values, we can see all of our y values end up being smaller than our original one. So we're going to say y is less than 5. The last part is just to detail those shifts. So we said that ours went up 5 and then left 2. So we want to write those in just like that. And this first one is done. The second one, I'm guessing you guys can do probably even a little bit quicker than we did the first one. So carry on and do that. Let's look at another set of problems here for a second. First one I want to look at here is problem number 3. Now, when you get to a problem like this, the name of the game is to get the square root alone. So we want to start by subtracting 9 from both sides, and we'll get the square root of x is equal to -9. Now, at this point, whenever you have the square root alone, the way you undo a square root is by squaring it. So you want to square both sides, and we'll realize that a square and a square root undo one another, so we're just going to be left with x. Negative 9 squared is a positive 81, and that is our answer. Now, with these problems, it's always going to say this: check for extraneous solutions. And the fact of the matter is you need to do this on every problem that has a square root. And what I mean by checking is to come back to the original equation and to plug in your answer. Square root of 81 is 9. 9 plus 9 is 18, which does not equal 0. So in this situation, this is not a solution. So we actually say that there is no solution to this equation. Now, looking at these other two problems, you'll have number 5, which will be similar. There's just going to be a little bit more work to do before you can get the square root alone. Number 6, the square root is alone, so you can square right away and solve. Looking over here at number 4, though, this one's kind of important to know too. Whenever you have two square roots, you want to get them on opposite sides and start by squaring them. When you square those, the 2 and the square root cancel out, leaving us with just 5x minus 3. And the 2 and the square root cancel out, leaving us with x plus 17. Now, our job is to get our x's on the same side, so we're going to subtract x from both sides. 5x take away 1x is going to give us 4x minus 3 equals 17. And then our job is to get x alone, so we are going to add 3 and add 3. And that will give us 4x equals 20, which means x equals 5. Great. We'll save those other two problems for you, number 5 and number 6. Let's look at the last page here. The last page says, identify whether each graph is linear, exponential, quadratic, or radical, and then match the equation with the right graph. Now, remember, when we reviewed these in class, linear always means lines. So as I look at these here, I can see that I have a line here, so this is linear, and I also have a line down here. So two of these are linear. Now, if we come over here and look at our equations, let's look and try to identify the ones that are linear. So this one is linear because it is y equals mx plus b, right? It fits that form. And then this one is actually linear. So this one's also y equals mx plus b. So now we just need to sit there and identify the differences. This first one has a negative slope, and it has a y-intercept of a positive 3. So looking at our two graphs, this one has a positive slope, this one has a negative slope, so that's kind of leading us to think that maybe that's the guy. And then we notice that we had a y-intercept of a positive 3, and if we look on our graph, we have a hit at positive 3, so this equation must go here. So the equation for this one is y equals a negative 1/2 x plus 3. Now, looking at some of our other ones here, I'm going to leave some of the review work for you to go back and work on your own. But we do have a couple of square root ones we can talk about. So obviously this is a radical equation. This is what this whole chapter is about. And actually so is this one up here. Now, when you're looking at this one and you get down to your equations, you can see your equations down here. Using what we know now, you should hopefully be able to get to an answer a little bit quicker than we did the first time. We know that this 3 is going to shift our square root function up. So if I'm looking at my graphs, which one has a square root function that was shifted up? Well, that's this one over here. So we know that this equation must be y is equal to the square root of x with the plus 3 on the outside, just like so. I'll save the rest of those problems for you. Your task for the rest of the day is to complete this worksheet and then get it completed, and we'll bring it in and submit it tomorrow. Thanks, everybody. Have a great day.